Hello, tech enthusiasts. Welcome back to T's TechKnow channel. Today, we're diving into the world of IP protocols, simplifying complex networking concepts like IP addresses, subnetting, and how the internet works. Buckle up, because we're about to make the invisible backbone of the internet crystal clear. First, let's talk about IP addresses. Think of an IP address as a unique identifier for your device on a network, similar to a postal address for your home. Just as mail carriers need your address to deliver letters to you, data packets need an IP address to find their destination on the network. There are two main types of IP addresses: IPv4 and IPv6. IPv4, or Internet Protocol version 4, is the most widely used. An IPv4 address consists of 4 numbers separated by dots, like 192.168.1.1. Each of these numbers can range from 0 to 255, providing over 4 billion unique addresses. While this seemed ample in the early days of the internet, we've since outgrown it, leading to the development of IPv6. IPv6, or Internet Protocol version 6, addresses this shortage. An IPv6 address is much longer, written in hexadecimal and separated by colons, such as 2001:0 db 8:85A3:0000:0000:8A2E 0370:7334. This format allows for an almost inexhaustible number of unique addresses, ensuring we won't run out anytime soon. Next, let's delve into subnetting. Subnetting is a method used to divide a larger network into smaller, more manageable subnetworks, or subnets. This improves the efficiency and security of the network. Think of it like organizing a library. Instead of having all the books in one massive section, they are divided into genres, making it easier to find what you need. Each IP address can be split into 2 parts: the network portion and the host portion. The network portion identifies the subnet, while the host portion identifies the specific device within that subnet. A subnet mask is used to define these parts. For example, in the address 192.168.1, with a subnet mask of 255.255.255.0, the first 3 octets, 192.168.1, represent the network, and the last octet, 1, represents the host. Now, how does this all tie into the way the internet works? The internet is essentially a global network of interconnected networks, or a network of networks. When you send an email or load a web page, data is broken into smaller packets. These packets travel across the internet, hopping from router to router, until they reach their destination. Routers play a crucial role in this process. They use IP addresses to determine the best path for data to travel. Each router examines the destination IP address of a packet and uses a routing table to decide the next hop on its journey. This process continues until the packet reaches its final destination. To ensure that data packets reach their destination correctly, several protocols work together. The 2 primary protocols are the Transmission Control Protocol, TCP, and the Internet Protocol, IP, commonly referred to as TCP/IP. The IP protocol handles the addressing and routing of packets, while TCP ensures reliable delivery by managing the data packets order and checking for errors. Another critical aspect of IP protocols is the domain name system, DNS. Humans find it challenging to remember numerical IP addresses, so DNS translates user-friendly domain names, like www.example.com, into IP addresses that computers can understand. When you enter a website URL, your device sends a request to a DNS server, which then returns the corresponding IP address, allowing your device to connect to the website. Let's also touch on Network Address Translation, NAT. NAT is a technique used by routers to translate private, local IP addresses into a single public IP address. This is particularly useful in conserving the limited supply of IPv4 addresses. When multiple devices on a local network access the internet, NAT ensures that each device's data packets are correctly routed to and from the appropriate device. Security is another vital component of IP protocols. Secure protocols like HTTPS, SSL/TLS, and IPsec help protect data as it travels across networks. HTTPS, for example, encrypts data between your browser and a website, ensuring that any information exchanged, such as passwords or credit card details, remains confidential. To summarize, IP protocols are the foundation of modern networking. They enable devices to communicate by assigning unique addresses, segmenting networks into manageable subnets, routing data packets across the globe, and translating domain names into IP addresses. Understanding these protocols demystifies how the internet works, making the complex world of networking more approachable. We've covered a lot today, from the basics of IP addresses and subnetting to the role of routers, DNS, and NAT. If you found this video helpful, give it a thumbs up, subscribe to our channel, and hit the notification bell for more tech deep dives. Feel free to drop any questions or comments below. Thanks for watching, and see you in the next video on TechKnow channel. Stay connected.